Have you ever stared at a piece of code and thought, who wrote this mess? Only to realize it was you? I have, more than once. And on one hand, it's quite embarrassing, but on the other hand, it can be really empowering because you've learned so much since you saw that code last. At least that's how I feel. Writing clean code is essential, but it's often overlooked. Today, I'm going to share with you 7 of my favorite strategies for writing cleaner code that's going to help save you and your team hours of frustration. So stick around because the last strategy is going to help transform the way you think about coding and development as a whole. So let's dive in. Hello world, I'm David Scott Bernstein. Here are 7 strategies for writing cleaner code. Number 1, adopt collective code ownership. Collective code ownership means that any team member can work in any part of the code, even if they didn't write it. The team should adopt the same coding standards so no one can tell who wrote the code. That's called collective code ownership. And it makes the coding style consistent and easy to work with throughout the code base. In addition to sharing a common coding format, teams should be working from the same domain model, have common developer practices, and share a vocabulary for describing designs. This helps so much. Collective code ownership really ensures that everyone on the team can work on any part of the code. This is a strategy that boosts team collaboration and fosters a shared sense of responsibility. But here's the kicker. When everyone can touch the code, it forces everyone to be more thoughtful with how the code is written. That's good. So what happens when developers fear touching each other's code? Bottom line, the project stalls. But when we adopt collective code ownership, this fear disappears. That's why if we want our program to act as a whole, our teams have to be a whole as well. There can't be holes in our knowledge. There has to be completeness in our knowledge. The whole that we have can't be the lack of. It has to be the completeness. That's one way to think of it. This isn't just about formatting. It's about reducing silos and ensuring that everyone feels empowered to go in and touch the code. We don't want people to be scared of working in legacy code. This is the code killer. This is the thing that destroys so many projects, which is the real fear of touching software, existing software. And the reason that it's a real fear is because most of us have this experience where we've gone in to try to make a simple change to an existing system and created more mess and more bugs than we started with, because of the intertwined nature of software. It doesn't have to be that way, but that's the way a lot of software is. As a result, developers are scared to touch code. And we don't want to be in that situation because the flexibility of our software really reflects the flexibility of our processes in business. And business needs that flexibility to be able to grow and change. Collective code ownership is one of the most important and valuable ways to ensure a consistency in our software development throughout a very large code base. And of course, the larger the code base is, the more important collective code ownership is. When you're working on a project solo, of course, your code can be quite consistent. And even when you have teams of 3 or 4, 7 people, when you start to build enterprise software, when you start to build systems that require 20, 50, 200, 500, sometimes my clients have thousands of developers who are working on the same code base. And having collective code ownership and understanding standards and practices is absolutely critical. I don't recommend creating a standards and practices document because you could spend a lot of time on it. Rather, let the code base itself or part of the code base that you think is clean act as the standards document, and then have everybody conform new code to that and slowly take the existing code and have that conform as well. And when you have that level of consistency throughout your code base, it is much easier and more straightforward for people to work with. It's a huge effort in a lot of systems, especially large systems, to do this. But it is an effort that ultimately can pay off huge dividends. I've worked in teams where they've halted all production because they realized how important this was. And they did it in 3 to 6 months. I've worked in other teams that said we can't halt any production. We have to continually produce new products, but we can use this as a value stream and devote 20% of our time. And instead of having it done in 6 months, they had it done in 4 years. But they had steady progress along the way. Having a commitment to clean up legacy code is one of the key characteristics of flexibility in software. If you're in a department that's all about putting out fires, then that's all your department will ever do. In order to really be effective, we have to be proactive and build software in such a way that it's resilient. This leads us to the next strategy, which I think is one of the most important as well as most misunderstood. Number 2, refactor joyously. Refactoring is a central part of software development and happens throughout the development process on healthy teams, on large and on small projects. Refactoring is really critical to keeping software agile when we're doing test-first development, where we make a failing test, then make the test pass, and then refactor for quality. It's built in to our development cycle in the small, and it should also be built in to our development cycle in the large. When we refactor, I find that on an active project, every 3 to 6 months, I need to go back into the code and work with the team to take what we've learned during that time and put it back into the code base. I find that it's a valuable practice to do because sometimes code can get out of sync with what we've learned and what we understand the system currently to be. And, I think on the teams that I've worked in, we learn in chunks. We don't learn in this nice gradual process, but suddenly we get these revelations and suddenly see something we didn't see before in our design or in the way we want to do something. And it's at those times when I find that it's really valuable to refactor the code so that not only the implementation, but the code itself, the domain model itself is reflecting what's going on. It's natural to, hack around in code and mess things up to figure things out. But what I like to do if I'm doing that is to back out later when I got something working and then clean the code up and make it so that it looks like I intended to do that all along. I get my implementation working, I get my tests to pass, and once all my tests are passing, then I am in safety. I know that everything is working, and if I make a mistake, it's very likely my test will break and tell me immediately so I can back it out. And when I get that level of feedback, I can move much, much faster. Think about being a cave explorer, right? Without a flashlight, without a rope, without a walkie-talkie, without any equipment. I mean, it could be very dangerous. And that's what it feels like when we're in software. Software is opaque. It's like walking into a dark cave, and any step might throw you into a hole or something, right? And the same thing is true in code. And so we need flashlights, we need support systems. And the way we see into our code, well, the way I used to see into my code was in the debugger, right? You get the perfect mirror there, right? You can see all your registers and all your variables and stuff. But unfortunately, it's out of time. And so the way I like to see my code now is by having it pass tests, good unit tests for the behaviors that I want to see in the system. And so I'm validating the behaviors that I intend to validate. Notice I'm not doing quality assurance. It's impossible to assure quality. That's not the slippery slope that I want to go down. What I want to do is just assure that the code that I wrote behaves as I expect it to, which is different. It's a much more limited set of activities than assuring quality, right? That's way too grand and huge. But I can assure that the specific code that I wrote works in the specific ways that I intend by writing good unit tests for it, by asserting that it does the things that I want it to do. And honestly, when I think about building software in that way, things become so much clearer. Suddenly I think about things in good, manageable, understandable chunks. And maybe it's just because I've become an old guy and my memory is horrible. You will too. If you stay in this field for any length of time, you'll need to rely on crutches as well. My very favorite and very best crutches is my unit tests. My unit tests show me, prove to me, every time I push the button and see all them run and see the green bar, they prove that my code works as I expect it to. And damn, that's a good feeling. And I've never found any other place, any other way to find that feeling. And when I say unit test, I mean, I'm testing the unit of behavior. So an acceptance test in an acceptance test framework is, in my mind, the same thing, except at a higher level as a unit test that I write using TDD. So to me, they're the same thing because I'm writing tests against the behavior, either the big behavior, the feature, or the little details of the steps to get to that big behavior in the unit tests. I have done behavior-driven development using unit testing frameworks. I haven't actually used behavior-driven development frameworks like Gherkin or SpecFlow or some tools like that to do unit testing, but I'm sure you could. I like to write a test for the smallest possible behaviors. And yeah, I wind up writing a lot of unit tests, but I have a lot of good coverage as well. But I don't have too much coverage. I find people spend too much time covering the trivial stuff and too little time covering the important stuff when they do unit testing. Unit testing is a set of concepts that I think everyone should understand because it's a way of validating our hypotheses. Unit tests to me are the process of triangulating, of taking a different perspective. This is what I think the ultimate value of software, one of the big values of software is, and of being a software developer, is that we get to exercise skills that broaden our perspective, that give us different points of view, which is the next stage of human evolution, in fact. It's the next stage of our ability to think more clearly. And if you haven't noticed, intelligence has a trajectory. This should be obvious to us, right? The way we think today is very different than the way we thought 20, 30, 40, 50 years ago. I can remember, but certainly wholly different than the way we thought 200, 500 years ago. I mean, just try to tune into that. We were very practical because survival was very critical for us. And so everything in the world had a very practical sense. We didn't think about the world in this abstract hierarchical pantheon of thought that we do today, where matter has constituents of atoms and subatomic particles, etc. And even though you may not be thinking about these things all the time, they do influence us in the inventions that we have, in the tools that we use. Our cell phones wouldn't work. We wouldn't be able to circumnavigate the globe without these ideas, right? So these ideas permeate all of our thinking, whether we're conscious of it or not. And so many of the new leading edge ideas are coming from our field. And that's why it's so exciting, I think, to be part of this field, is that we get to peek at some new ways that thought is emerging. I think it's very exciting. So just think in terms of how humanity, how culture, civilization has thought abstractly, has even thought, through logic and reason over the last several centuries. And notice that there's some huge changes. What is the direction that we're going? More abstraction, more ability to see the interconnection between things, more integration. All of these things are the key skills, and the world is in desperate need of them. These are the things that actually we are well versed in as software developers. It's so funny. Our jobs are not going to go away. Everyone's going to be a software developer, but it's going to be a different kind of job. It's not going to be where we're twiddling bits and worrying about bytes and manipulating registers. It's going to be about solving problems. But the problems that we'll be solving are going to be much, much bigger, much more exciting, and it's going to have much more value. This is such an exciting world and time to be in. And I think that the field that is going to be the highest growth field is going to continue to be software development. It has been the highest growth field for the last 2, 3, 4 decades, right? There have been more computer science graduates. There's been more demand on computer science and software developers than pretty much any other field. And I don't think that's going to stop. I think that it's going to change quite a bit. Just like it changed in the 90s, that I experienced in the early 90s, when we went from procedural languages like C and Fortran to object-oriented languages like C++ and Java. These languages gave us more flexibility to build more agile code in a larger enterprise. This is just the next step, you know? Refactoring is a central part of writing code and happens throughout the development process, in the large as well as in the small. When I'm using test-first development, I'm refactoring as I'm going during the red-green refactor cycle. But at the same time, I'm refactoring in the large every 3 to 6 months typically when I'm working on a project. Refactoring is not an excuse for writing messy code. It teaches us to build supportability into our code so that it's easier to work with later. That's essentially the goal. We want to refactor to continue to make our code reflect what it is that we're modeling. Refactoring is often seen as tedious, but it's key to writing cleaner code. As a developer, we sometimes think, oh, I'll fix that later. But then when later comes, the code has already become really hard to work with. Certain things I think warrant refactoring before I leave working with code, and other things warrant coming back to. So I guess having worked with doing a lot of refactoring, I think about refactoring in terms of layers. There's the safe refactorings, the easy refactorings, and then there's the harder refactorings. Oftentimes, the harder refactorings are flaws in our domain model or something fundamental that's wrong in our design. Whereas the safer refactorings help me just sort of keep my code clean and workable. I especially find test-driven development helpful during this part of refactoring. When all my tests are passing, I can refactor code, and if I make a mistake and change the behavior, my test will break, and that will alert me so I can easily and quickly fix it. I don't think developers really see the value of having a system that can alert you instantly to making a change in the behavior of code. When you are able to do this, when you have the right tests that test the behaviors you want to validate, and if you make a mistake and getting that instant feedback on that mistake, most of the time, developers will fix that mistake without even realizing it, that they fixed a major bug. A bug that could be a major bug if it were to escape into production, or even if it were to be brought back to the developer, a week later when they're not thinking about it. Because to ramp up and find that mistake can take enormous amounts of time. Being told in the moment, getting instant feedback, that is so amazingly valuable. People are in awe at the superpowers I have as a software developer. And honestly, it's not me, it's my tools. Honestly, having this level of feedback that you can get from a good test space, and either your tests, when you write them, will destroy your code or it will support you in agility. The same medicine that can cure you will kill you if you use it wrong. And the same thing is true for any complex activity, Look at surgery. You can't just blindly cut into a person. You have to understand the organs and all sorts of things that I don't understand. But that's why I'm not qualified to be a surgeon. And that's why a lot of non-software developers are not qualified to write code, because we don't understand the key things that make up maintainable code. And that's what we're focusing on in this channel. So if you are supporting that, if you like that, please like and subscribe. Your positive actions for liking this video will be a signal to YouTube to bring it out to more software developers so that others can benefit from this knowledge as well. We want to try to build an industry, and I really want people to come together. I'm speaking to my core audience, who are senior software developers, people like me who've been in the field for a long time and who understand the importance of writing maintainable code and want to be able to learn how to do it well. But I also understand that other people who are not senior developers still want to understand these things. If you're starting out as a developer, or even if you're a non-developer, but you manage developers or work with developers, or want to start to leverage AI to develop your own software, I want to help you. I want to be able to give you information and wisdom that will help you build software that's scalable, that is not just a one-off, but you can build a foundation on. To do that, to me, it's the key practices of extreme programming, really. It's thinking about good architecture and design. It's about understanding how to emerge designs by taking the perspective of the assertions that I write. So there's a range of techniques for being able to do this. And when you're initiated in those techniques, when you learn how to do them, I find that life becomes far better. Software development becomes far easier because we start to really understand how to influence good code. And the code that we write starts to become more maintainable, more extendable. We spend less time putting out fires and fixing bugs and more time creating new things. That's what we want to be able to do. This is going to become even more important when we start to build much more complex systems, which is going to happen as we start to become better with artificial intelligence. AI is not going to cut away our jobs, but it's going to make our jobs much more challenging because we're going to be able to solve much bigger problems. And in order to be able to do that, we have to be able to understand and write good designs. Okay, so to me, test-driven development is really a no-brainer. It's one of the key things that is going to help us allow AI to get aligned with us, because we'll be able to define the assertions and say these are the behaviors that we want to create, and these are the standards for those behaviors. And then AI will be able to create implementations for those behaviors. But in order to do that and be able to create an industry that we can build upon, we have to teach AI how to build good software. We can't be completely reinventing the wheel over and over and over again, which is what I see in most companies. And remember, again, I get to work at the top companies, right? These are, let's say, big Fortune 100 companies, as well as other smaller companies, people who are trying to be on the leading edge. Speaking of teamwork, the next strategy takes collaboration to the next level. And it helps you avoid some of those last-minute bug-fixing marathons that so many of us have lived through, barely. Number 3, pair constantly. Pair programming is the fastest way I know to propagate knowledge across a team. Pair with different people every day until you find the people you pair best with. But still pair with different team members occasionally in order to continue to learn from each other. Some teams pair on all tasks. Other teams pair on only specific tasks, but you should pair at least always when you're doing debugging or refactoring or testing or designing. Those are the ones that are most valuable for me when I pair. Pairing and mobbing are the fastest ways that I know to level up a team's coding skills. You don't have to bring on a fancy consultant. You can learn from each other. By working with different partners when you're pairing and picking the best practices, you'll be less likely to get on bad habits. Does pair programming actually slow a team down? This is what I hear from managers a lot. Managers say to me, I can't afford to lose half my resources. Well, first of all, we're people, we're not resources. And secondly, pair programming is not about taking turns at the computer. It's about taking two minds and bringing it to solve one problem. There are many physical challenges that require two people, right? The credenza behind me, the big shelf behind me is certainly too heavy for one person to lift. That's clearly a 2 or more person job. And there are many intellectual challenges that are just as unwieldy as trying to move this big furniture behind me. Pairing is not just about when you're writing code. Pairing is also very helpful when you're doing design, when you're doing debugging, when you're talking about and thinking about what you want to do and how you want to do it. Some teams even pair on all tasks. It's also an amazingly powerful way to learn and to propagate good practices and code consistency throughout the team. These are the things that managers tell me they want most. They want consistency. They want to be able to break Brooks' Law. Brooks' Law is affectionately attributed to Frederick Brooks, who wrote the book Mythical Man Month, which has Brooks' Law is all about when you bring more people on a team for software development, it tends to slow the team down rather than speed it up. This is pretty intuitive for us as software developers, but people who are not used to software development have a hard time understanding this. They think that writing software is like manufacturing, where you're doing this repetitive task over and over again, which you can easily estimate. And a lot of times, managers who don't understand the nature of software development, and they ask us for estimates, and we go hem and haw, and you go, and like, oh, well, I don't know, and maybe take a week or a month. And they think that we're being evasive. We're not. We literally don't know because we've never done this before, right? And how do you estimate something you've never done before? Maybe there's a framework that will do it for us. Maybe we have to reinvent the wheel. Maybe we have to pioneer something ourselves. All of these things take time. And I say that the most accurate estimates are the ones where you actually think through it in enough detail that you actually do the task. But it's also very expensive, right? And so the fidelity of estimates are really important because we don't really want to pay for high fidelity estimates. We can make them, but they're damn expensive. And so we don't want to pay for them. And instead, what we want to do is really find the best process, create a software development process that we can rely on, that we see is effective. And then it takes as long as it takes. If we need to make estimates for planning purposes, and a lot of times we don't, but if we do, if we need to, come up with a marketing campaign and know how we're going to time that with the delivery of our software or whatever, I think that the best way to deal with that is to use yesterday's weather. It's the most accurate of all, which is look at how much we got done in the last iteration or the one before it, or the average of the last 5 or whatever. And that's probably how much we'll do in the next sprint or iteration. And because of that, we don't have to spend a lot of time interrupting developers, asking them to make estimates. We can just use real data. Now, estimation is valuable, not in the sense of, we're going to make these delivery dates carved in stone. Estimation is valuable because it forces us to think through the problem. And the more we can do that up front, the better we can start to understand as we're building the details. But the details are subject to change. They're always subject to change. When we know that, we understand that that's how healthy software development works, that we're constantly making changes. Now, this is not how other manufacturing works. In standard development and hardware development, we want predictability. In software development, actually, we don't want predictability. We want the ability to be flexible, which is a different set of tools and skills. And one is typically at odds with the other. So if we have to choose between a highly predictable system or a highly flexible system, what do you think is better? Clearly the highly flexible system, because we don't get all the information up front. We don't actually learn the truth until much later in the development cycle, sometimes until after we're done. And so the ability to make those last minute changes is absolutely critical. If it's not feasible to pair program all the time, then I have another practice that can help catch bugs early before they turn into big problems, which is this next practice. Number 4, do code reviews frequently. Code reviews are still valuable even when you pair and mob on everything, because it gives other developers a chance to see other parts of the code that they didn't directly work on. Code reviews should focus on the reasoning behind the decisions that were made and discuss design options and trade-offs to help us understand the philosophy of design that was selected. Code reviews are ways of sharing knowledge and information. Even when you're pairing, code reviews are vital. There are ways to keep up on what the team is doing and understand. It also gives fresh eyes a chance to look at your work. But code reviews can be abused as well. And if you're interested on my strategies on code reviews, check out this video here, because I just made one. So code reviews should be more than just about catching bugs. And they should be an opportunity to learn from each other. Focus on reviewing concepts rather than syntax. Encourage discussions about trade-offs. Is this the simplest way that we could solve a problem, or are there more straightforward approaches? Use reviews as learning opportunities, not just as a way of doing critiques. We want to discover the best ways to truly understand what clean code is, which leads us to the next strategy. Number 5, study other developers' style. Reading other people's code and learning how other developers write code is a great way to improve your own skills and level up as a developer. Virtually every developer has his or own style or way of doing things that we can learn from. Learning how other developers address certain issues can make you a much better developer yourself. We all have unique coding styles, but the best way to improve is by learning from each other. Whether you're reviewing open source projects or your own teammates' code, understanding different approaches will broaden your perspective as a developer and make you a better developer. Have you ever noticed that some developers seem to solve problems effortlessly? Often it comes down to learning some of the best key practices. Read other developers' code to get insights. Identify common practices, but also spot inefficiencies to avoid. Shadow senior developers and ask questions. Having a senior developer on your team can be priceless to learn from. So find ways to bribe them. And that's been my technique, finding ways to make their life easier in exchange for learning from them. And that's how I've been able to learn from some of the best. Now, take it a step further. Improving skills constantly means pushing boundaries of our knowledge. Number 6, study software development. 20 years ago, there were a few good books on software development that were must-reads, in my opinion, for developers. Today, there's hundreds. Being a professional software developer requires ongoing study. You know, doctors devote 8 to 10 hours every week to reading up in their field, and we software developers should do the same. This is critical for people in our field. And if you don't like it, then find another field, honestly, because it really is required. And it's not going to change even when AI comes out, because AI is going to teach us to learn more and more, faster and faster. And that's going to be good for our industry. If you're not investing time learning outside of work, you're missing out. There are best developer books to read. I have recommended many different books. Here's a video on my favorite 5 developer books. There are courses. There are lots of YouTubers who are coming up with great information in software development, in AI, bridging the gap between the two. What are the best skills to learn in the future? Well, you need to know the basics, and I'm not going to cover those here. There's a lot of YouTubers who are teaching the basics. And there's a lot of YouTubers who were teaching the basics 4 and 5 years ago that are, or 3 years ago, that are, covering more advanced stuff. But you can go back into their earlier works, Tech with Tim and Arjun Codes and Emily Bache and Continuous Delivery and so many other great channels. There's so many great technology channels that really can give you a great background in software development. You don't need to go to, a bachelor's degree in software development. And more great people are doing and talking about the things that I'm talking about as well, which are, I think, advanced skills for writing maintainable code, which is quite important. And it's causing me to go even further and start to focus on things that, again, I want to focus on things that other YouTubers and other people in the field are not focusing on, because there's a lot of opportunity there. So creating good encapsulated domain models, I think, really valuable to talk about. So the skills that I want to focus on are, I think, the key skills for writing maintainable code with or without AI. And eventually, I want to make everything that I do available for free, because humanity needs these ideas. These are important, and I recognize that. So I want to share them with everyone for free. But it's going to take some time. It's going to take some time because I got so much to share, and I only got one mouth. And while I'm making videos, if you want to dive into some of the deeper stuff, if you want to learn some of the key stuff that I think is most important, then in the description there's a link You can make an appointment with me. We can do coaching sessions. You can sign up on my mailing list to learn about courses when they become available. I've taught courses on design patterns and extreme programming practices like test first development and refactoring for many years. And they're unique and incredibly powerful. And I'm starting to make them available to the general public. So if that's of interest to you, go to the show notes, go to my website, tobeagile.com, and sign up for in my newsletter. You'll be able to get on my mailing list, and I'll tell you about upcoming courses. And if you want to learn about other things that I'm working on or be able to bring some of these ideas to your work, we can talk. I can do coaching with you. I can help your team become more effective. I'd love to be able to do that. The first consultation is always free. If you have a team of software developers, I'd love to talk to you. I have helped so many developers at so many of the organizations that have written great software throughout the world. I'd love to help your organization as well. Constant learning. This is the attitude that really is key for being a software developer. And I think it's one of the things that make or break. This is one of the things that you really have to love, constant learning. Just like doctors, we have to keep up with new technologies all the time. We have to be constant learners. For me, the key skill here, the one thing that I can give you as a really golden nugget is that you have to get good at unlearning. Finding the things that were really successful for you, the key skills that brought you to where you are, oftentimes are the other skills. These are the skills that prevent you from learning the newer skills that are even more effective. And so learning how to unlearn those skills, identifying what they are, so that you can learn the new skills, I have found is really key to becoming a master developer and to being on the fast path of learning. Then you're not just repeating your 5th or 6th year as a developer over and over again, but you're actually learning and growing. That's a challenge. Learning how to unlearn. And it's a whole set of skills, just like learning how to learn is a set of skills. So if this is of interest to you, I could make a video on that. And if you're interested, put it in the show notes. Put it in the comments. Tell me that you would like to have a video on learning how to unlearn, and I will make one. Finally, number 7, read code, write code, and practice. In Stephen King's book on writing, he suggests that in order to be a great writer, you should read a lot and write a lot. When Henny Youngman was asked how to get to Carnegie Hall, he said, practice, practice, practice. The same is true with software development. Read other people's code, write code, and practice. Someone asked me, where do I read other people's code? Where do I find good sources of code? Code that I would be proud of to have written myself. I can't point you to many directions. I've looked on GitHub. I've looked on many repositories, and I haven't found a perfect repository for clean code. Yeah, there are some, I think, XUnit and some other, code that was written by good ex-peers could be a good place to start, but I don't have any really one big source for writing clean code. So what separates great developers from just good ones? Is it the sheer amount of time that they spend writing and reading code? Or is it the connections they make and the deeper understanding that they get? Practice doesn't always make perfect. When we practice, we also have to make progress. We have to be able to see things in a new light. We have to learn and grow. We have to do what happened when I started out and see code that I look at and I go, ooh, that's really messy. Who wrote that? And I realize it's me. I wrote it. Because when that happens, it means that I got better from the time I wrote it to now. And that shows that I have progress. And that is a good feeling, as well as being embarrassing. It's both. How do we get better? Read code, write code, participate in coding challenges. Clean code makes life so much easier for you and your team. It reduces bugs, it speeds up development, and it improves collaboration. So what strategy are you going to apply first? In this next video, we're going to dive into a topic that every developer needs to master. So check it out. Don't miss it. And I'll be in the next one. So see you there.